In this tutorial, we will briefly see how to use the ZTable to work operations management problems. This tutorial will be somewhat different from the other tutorials. Business statistics is generally a prerequisite for operations management, so you should have covered this material in a prior course. So, my purpose here is not to teach you everything you need to know to use a ZTable. Rather, I will just be focusing on using a ZTable for the few tasks where it is used in operations management. ZTables can be presented in a variety of ways. They yield the same results, but the steps to use them are somewhat different. The ZTable we will be using is shown on the slide. A PDF version of this table is available for you to download and print. You should do that before continuing. ZTables have three main uses in operations management. 1. Finding a Z-value to use building a control chart when a specific probability is given. Most control charts use Z equal to 3, but any value can be used. 2. Finding the Z-value to use when setting up the level of safety stock. And 3. Finding the probability of a stockout given a calculated Z-value. We will see how to use the ZTable in each of these situations. Finding the Z-score to use to build a control chart of a given probability, say 95%, is a three-step process. 1. Take the given probability as a decimal value and divide it by 2. So 0.9500 divided by 2 equals 0.4750. 2. Take this value and find it on the inside of the table. We will switch to the table in a moment to see this. If the exact value is not in the table, just find the closest value. And 3. Read the corresponding Z-score off the side and top of the table. The exact value of 0.4750 is in the table. We get the first part of the number, or 1.9, from the left side of the table. We get the second decimal point, or 0.06, from the top of the table. That gives us a Z-value of 1.96. Now, you try to find the Z-scores for a control chart at 80%, 90%, and 99%.
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
.8000 divided by 2 equals 0.4000. The closest number in the table is 0.3997. That gives us a Z-score of 1.28. 0.9000 divided by 2 equals 0.4500. The closest number in the table is either 0.4495 or 0.4505. Since they are equidistant, we will just arbitrarily use 0.4495. That gives us a Z-score of 1.64. Using 0.4505 would yield a Z-score of 1.65. 0.9900 divided by 2 equals 0.4950. The closest number is either 0.4949, which we will use, or 0.4951. That yields a Z-score of 2.57. The steps for finding a Z-value to use for safety stock are very similar. For those of you who recall your statistics, the only real difference is we are using a one-tailed Z-value rather than a two-tailed Z-value. 1. Take the desired service level and subtract 0.5000. So if your desired service level was 95%, then 0.9500 minus 0.5000 equals 0.4500. Note that if you were given the probability of a stockout rather than the service level, you find the service level as 1 minus the probability of a stockout. 2. Find this value inside the table exactly as before. And 3. Read the Z-score exactly as before. Looking up a value of 0.4500 for a 95% service level gives us a Z-score of either 1.64 or 1.65, depending on if we pick 0.4495 or 0.4505. Find the Z-scores to use with a service level of 80%, 90%, and 99%.
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
.800 minus 0.500 equals 0.3000. The closest number is 0.2995, yielding a Z-score of 0.84. 0.9000 minus 0.5000 equals 0.4000. The closest number is 0.3997, yielding a Z-score of 1.28. Finally, 0.9900 minus 0.5000 equals 0.4900. The closest number is 0.4901, yielding a Z-score of 2.33. To find the probability of a stockout, we start with a Z-score and work the other direction. 1. We take the given Z-score, say 1.88, and find it around the edge of the table. We then find the associated number inside the table. 2. We add 0.5000 to that to get the associated service level. 3. Subtracting that number from 1 gives us the probability of a stockout. With a Z-score of 1.88, we use the row for 1.8 and the column for 0.08. That yields a value of 0.4699. Adding 0.5000 gives us a service level of 0.9699, or about 97%. 1 minus 0.9699 equals 0.0301, or about a 3% chance of a stockout. Find the associated probabilities of a stockout for z-values of 1.08, 1.23, and 1.39.
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
A z-value of 1.08 yields a value from the table of 0.3599. Adding 0.5000 yields a service level of 0.8599, or about 86%. Subtracting from 1 yields a stockout probability of 0.1401, or about 14%. A z-value of 1.23 yields a value from the table of 0.3907. Adding 0.5000 yields a service level of 0.8907, or about 89%. Subtracting from 1 yields a stockout probability of 0.1093, or about 11%. A z-value of 1.39 yields a value from the table of 0.4177. Adding 0.5000 yields a service level of 0.9177, or about 92%. Subtracting from 1 yields a stockout probability of 0.0823, or about 8%. Z-tables are far more useful than this brief tutorial indicates. For more information, consult any business statistics textbook.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.